I am Chris Winslett. I'm at Winsletts on Twitter. Okay, I work at Compose. We're a database as a service company. We run databases for customers in data centers. If you need a database, like if you need a MongoDB database, Redis, Postgres, Elasticsearch, or Rethink, you can come and just sign up and start using a database. It's interesting. When we started in 2010. We started with MongoDB. When we started, it was a novel idea to actually run databases in data centers in the cloud, have a database as a service. Now it's just kind of, that's the world we live in. You can just go get databases. Before this, it was, you actually had to work hard to get a database to stand up. Now all you have to do is put in a credit card. So we started running with MongoDB in the beginning. So we just had MongoDB. We had no other databases that I mentioned a moment ago. We always intended to run multiple types of databases, but we just ran MongoDB for a long time. It was fortunate that we started with MongoDB because at that time, people were trying to use MongoDB for everything. Like they were trying to use it for their core application database. They were trying to use it for a time series database. They were building graphs in it. They were doing a lot of different things. And also, MongoDB it's a naive database, so it's very rudimentary in the way it uses CPU, I/O, and RAM. This allowed us to focus more on building a general platform for databases than just one for Mongo. So it was actually quite good that we started with that. The reason we got to this particular point in our life with Transporter is because we recognized that people needed multiple databases. Because they were trying to use MongoDB for everything, we realized that a single database, we already had this knowledge, but it really became a conviction of ours that a single database cannot serve all the purposes of modern applications. So modern applications are going to have queues, they're going to have job processes, they're going to have analytics coming in, they need search, they need all these things that a typical database just can't fulfill at scale. So part of our story is building out with multiple databases and getting your use case into the database that works best for that use case. So what is Transporter and how does it fit into that story? So Transporter is an ETL tool. If you're an old school IT guy, you've worked with plenty of ETL tools. ETL stands for extract, transform, and load. So you extract from one database, you transform your data, and then you load it into another database. We were looking for something along the same lines once we actually started running multiple databases. We wanted customers to be able to use MongoDB, and then we wanted them to be able to experiment with like Elasticsearch. So what is Transformer? It's an ETL that works with these modern databases, and it's database agnostic, it's vendor agnostic. It's also open source, so you can go see the source code here, you can download a version of it, you can check it out. The reason we really went and built our own was because all the ETL tools out there are kind of vendor lock-in. So if you can see Microsoft's ETL tool, you can see Oracle's ETL tool. There's a ton of BI ETL tools out there. So we just needed something that just worked for our platform, and we also wanted to make it extendable to everyone. So in its simplest form, a transporter looks like this. So you go from source, so your source database, you transform your data, and then you put it in your destination database. In a more complex form, transporter could look like this. You could have multiple source databases, you could have multiple transformations, and you can have multiple destinations. So it's interesting how we put it together. So what is Transporter really? So Transporter is really more of it's a prescription for how you can set up data adapters, transformation processes, and a data pipeline. You can use it to do building blocks for anything you like. You could even add like an HTTP endpoint for a particular source that would go in as a data packet into the pipeline. It would get transformed and put into a destination database. So why Transporter? The reason we did Transporter is because in the beginning, we wanted to get data of a customer's from a production Mongo to like maybe a development Mongo. So the tools that were baked into Mongo did not make that happen all that easily. So we needed something that would just basically copy data. Then we launched Elasticsearch. When we launched Elasticsearch, we had customers that said, how will this solve our problems with MongoDB? And we said, it'll solve all your problems. You just have to get your data over there first. And they said, how do I get my data over there? And we said, that's a good question. So we went and built Transporter. And now, because we're in a multi-database world, we actually have adapters for many different types of databases. And this past week, working on building up to this presentation, I built an adapter for Postgres that we didn't previously have. So I'm excited to show that off. So how does this fit into Compose's worldview? So our worldview is that while helping customers scale their databases from a small application data set to a large data set, after general optimizations like building indexes, the next step is finding use case specific databases. So you have your main application database. When you start plucking out particular use cases, and you start putting those into particular databases that match those use cases. Be it time series data, be it your metrics that go into time series data, your search part of your application, just everything. You start seeing if those use cases match the particular database that you're using. So now let's get data from Postgres into RethinkDB. And we're going to do that using Transporter. So that's the full link to the tutorial. So this is the full link to the tutorial. The shortened link is there with the Google short link. So we're going to move data from Postgres to RethinkDB using Transporter. Basically, we're just going to walk through all these steps. I'll describe some of the pieces, some of the components that we use as we kind of walk through this. Let's see, let me close that. Side note, let me step back. If you're looking for the main branch, the main code base, it's here at compose/transporter. The reason we're working off the Winslett branch that I have right now is because I've been developing on it in the past week. If you're seeing this at any other time other than like August of 2015, this tutorial will probably be in the master compose transporter branch. So just know that for the future. We'll set up a nice little redirect from that old one to make sure you get there to the right place. So set up a working directory. Hold on, wait. Okay. Okay, so projects. So mkdir transporter test. Okay, so cd transporter test. Now we're in this particular directory. Is that big enough? That's big enough. Okay, so we need to download this particular beta patch. Okay, so copy link address. Oh. Get tar. Okay, come on. XVF transporter. Forgot X. Okay, so I'm transporter tar. All right, so now we have our transporter binary here. Again, if you want to go look at the code for that binary, you'll see it in that particular repo. It's all Golang code. So it's all Golang code, but your interface to it is Node.js. So you'll see a Node.js packet for that in a moment. Okay, so now let's go back over here. Let's install Postgres. So initdb -d initdb-d Postgres. Okay, so now we're initting a Postgres database. So now we go back. Let's see, wall level. So we're going to set these two variables in our postgres.conf file. The wall level logical is actually a new feature in 9.4. That logical replication actually gives us the ability to trail Postgres with a replication slot and see the changes that are happening to our data. So we're actually going to use that new feature in 9.4 to take data that's getting modified in Postgres, throw it into our transporter, and then transporter will eventually write it to Rethink. So let's go to our Postgres data, Postgres conf. Let's see the wall level. So we're going to set that to logical. By default, it's not set to logical. And max replication slots, we're going to change that to 1 so that we have replication capabilities. And then we're going to start up Postgres. Okay. So now our Postgres is running. And then our next step is to connect to it and create some data. or create some data, create something to copy. So let's do PSQL, Postgres. I'm going to copy in my information here. This is actually a bucket of a bucket of code. So connect or create database, my source database. Then we're going to connect to my source database on Postgres. We're going to add some data here. And then we're going to create this replication slot, this logical replication slot. This is the feature that was added in 9.4 to Postgres that makes tailing the changes to Postgres interesting. This is the name of the slot we're going to use. And then the test decoding here is actually going to be the plugin that we're going to use with Postgres. Every Postgres in 9.4 ships with this test decoding. So we chose to use it just for compatibility purposes, so that everyone can just use it. Now, let's install. We've got some rethink install code here, but we're just going to start running it. So mkdir rethink. So rethink db d rethink. So we're going to start running rethink. That's how easy it is to get started running rethink. No excuses to not use it. It's pretty nice. Okay, so from that, we need to create a destination database for our rethink. So we're going to go localhost 8080. This is the rethink administrative dashboard. So from here, we're going to go to tables. Can you guys see that? Yeah. From here, we're going to go to tables. We're going to add a database. We're going to call it mydestdb because everyone likes to shorten things. And then we're going to create a users table with an ID as the primary key. So users, ID, create table. Okay, there's our table. So that's how easy it is to get started with Rethink. We've got some data in there. Next, we're going to follow along with the next portion of this tutorial, which is create a config file. This is where we start actually integrating with transporter. So what we're doing with this config.yaml file is we're defining some data nodes. So we're going to have a Postgres data node and a Rethink data node. It's funny, we have URI right there for Postgres, but if you know what a URI looks like, that is not a URI. I've already been told that. It's like, yes, that is correct. That is the JWC connection string. We're going to work on that terminology, that code there. But for the meantime, let's pretend that's a URI and that it works. Okay. And then Rethink, we have our type Rethink, and we have our URI there. That is actually a URI. So we're going to make that config.yaml file. I'm going to create a new window. So we've got our other databases running in our old window. We have Postgres on the top, Rethink on the bottom. In this new window, we're going to start modifying some transporter test. So we're going to start modifying some files here. So I'm going to create this config.yaml file with the code that was in that tutorial to define our two nodes. And now we're going to create a file called application.js. And this actually defines the pipeline that we're going to use for transporter. So the source here says that we're going to use the data source name Postgres. We're going to tail the namespace of mySourceDB, which we created earlier, in the schema public with all table changes. We're going to tail it, so true. That means we're going to follow continuous changes to it. So we're going to dump the data initially, then we're going to follow continuous changes. We're going to use the replication slot, Rethink transporter, which is what I talked about earlier, with the logical decoding that's been added in 9.4. So that will make it easy for us to monitor these changes and then modify them. So then we're going to save it into Rethink, into this mydestdb, and we're going to save it with the exact same thing. So let's get started with that. Let's see if it works. Cross your fingers, guys. Okay. Now this is the code that we're going to run right here, or the command. So we have /transporter and then run, and then we give it the config file in the application.js. Come on, Yahtzee. Don't fail me now. Okay. Everything looks right. Let's make sure the data got over into transporter. So exporting data from matching tables. So it found the public users table, so the users table that we had in the source database. And now it's listening for changes on the logical replication slot. It would migrate any changes. So let's go look at Rethink's administrative dashboard. And they have this nice little thing called Data Explorer in the Rethink dashboard. So let's see what happened. Oh, my query's already there because I've been testing this all day. So the query that I'm actually running is r.db from my deskDB table users. Let's run it. And there's the code, or there's the rows that were previously in Postgres are now here. So now, let's go to our Postgres and make a change. So PSQL, connect my source database. Can you guys see that? Yeah. So update users, set name equal JSON. That was a typo. Where ID equal 1. Oh, just 1. So currently ID 1 is equal to Chris. That's me. So let's make a change, see what happens. Okay, so it updated 1 here. The update just came through transporter right here, update on public users. Let's see what happened here. So what actually happened here is a duplication of data. It created another record. So this is where we get to use a transformer now. So we get to use a transform.js right here. So that was staged, actually. That was not a impromptu failure. That was a planned failure. Thanks. Okay, so we ran the query. We have duplicate data now. So we did this. Go back to Rethink, run your query. You'll see duplicate data. This is where we're actually going to create a transform.js. So let's go here. Let's stop our transporter, transform.js, set paste. Someone's at the door. Okay, so this is our transformer code. What we have here is we're doing module exports. So if you're familiar with Node or with JavaScript, you see module exports. That means we're exporting this particular function. It's going to be the main function that gets executed. It expects to receive a doc. That doc in the transporter has a couple different information. It has a namespace information, which is basically a table. So this transformer could change where the table destination is. It also has it also has all the data for that particular row, so you can modify any of that data. And then what you do at the end, you return the doc, and then that basically just sends it on down the pipeline. So if you guys are familiar with ETLs, you'll know exactly what I'm talking about. So we have our transform data there. But now we actually also have to modify some of our application data, or some of our application code. So this is previously what it was with our application.js. We started with the source information up here, and then we just did directly to pipeline save. What we're actually going to do now is modify that and put a transform in there. Okay, so now we put a transform before the save, and we're filtering by public namespace. We tell it the file name that we need to execute from, and then we're going to save it. So hopefully this will do what we need it to do. So let's go back and delete this data here. Why public dot? Oh, that's a great question. Okay, so here, this public dot dot right here. So we're still working on this portion of it, but what happens is the namespace actually gets split by the first period. So it assumes that, yes, it assumes that that first period, what's before that is, no, I'm sorry, it gets split up here. So this one is the database. What I'm doing here is I'm matching all the public tables that come in. So anything only on the public Postgres schema. And then the dot here is just anything after it. So it's kind of a rough regex. Yeah. So it's if we change this, so if we had another table on that database and like a foo schema, and it first it would never get tailed because we don't have public. We have public up here. But if it made it to here, it would actually be rejected from the transformer. So the transformer would just filter out that particular table. So it's a way of doing filtering. Let's see. So let's go to our rethink data, drop our database, and then, let's go to our rethink data and actually recreate it. So it's recreating the table with a primary key. And now let's go to table users, and you'll see that there's no data in here. Okay, so no data in here. So that's exactly what we want. And then we're going to rerun our transporter again. Transporter. Okay, we've got all the information we want. Exporting public users, listening for changes on a logical decoding slot. Rethink transporter. We come back here, run our query. We'll see that, oh, this is looking better so far. So the underscore ID is the numerical value that was associated with the rows that were created in Postgres. And then if we modify our users, so it was Chris, then we changed it to Jason. Let's change it back to Chris. So, and you'll see over here that it is Jason on 1. So let's change that. Go run a query here. And it changes to Chris. So now what we have is we have data that's being written to Postgres, and then our transporter is actually copying it to Rethink DB. So today, if you have a Postgres database and you want to play with Rethink with your real data, you have a reason to. You have a way to now using this transporter. You kind of go into the tutorial, try toying with a couple of things. Don't try it on your production Postgres yet. Like ease into it first. Make sure you feel comfortable with it. Okay. And then, so we finished the tutorial. If you give it a shot at home, see how it works. Okay, let's see where we are back in our demo. And we're hiring. If you think any part of this presentation could be done better, if you think the code can be written better, we'd love to hire you. And that's it. Thank you.